Hey guys and girls, today's video is going to be about standard form. You should have completed an exploratory activity on Desmos yesterday. I don't intend. It is possible that I might send you some kind of other video about Desmos if I have time. No guarantees though. But today we're talking about standard form based on what you explored yesterday. So standard form for a quadratic function looks like this. This should not be shocking to you because we talked about standard form back in Unit 7. So that's what standard form looks like. It's a quadratic, again, because quad in Latin, it means square. So this is a quadratic function. In this quadratic function, A, B, and C are just numbers. So there. We normally learn how to find the vertex using negative b over 2a. This year, we're going to scrap that whole thing, and we're going to give you the vertex, but expect you to find certain other things if we tell you what the vertex is. So, what is it that you know about a graph when it is written in standard form? Excuse me, this should actually be written a little bit better. What do we know about a graph of a quadratic when the function is written in standard form? That would be a better way to state that. The y-intercept is always going to be 0, c. Because remember, the y-intercept is what we get when x is 0. If we put 0 in for x here and here, both of these terms will go away, leaving us just with c. So c would be the y-intercept. Does this open up or down? This isn't going to be shocking because we took notes over this the last time. If a is less than 0, the graph opens down. In other words, if a is negative. If a is greater than 0, the graph opens up. Shocking. A little shorthand for you there. How do we get 2 additional points? This is very simple to do, and if you just follow along with me, you will see. We actually have already talked about this a little bit. You move left and right 1. You move 1 unit left and right from the vertex, and then up or down absolute value of a units. In other words, we move down if a is negative, up if a is positive. So that shouldn't be surprising. And how do we get a potential 5th point? Well, you would have plotted the y-intercept. You can get a potential 5th point by reflect the y-intercept over the axis of symmetry. So for the rest of today, I'm just going to show you examples. If you feel extremely comfortable after the first example, you really can be done with the video. But there are 2 more examples that I will go through on the back page. All right, so here we have y equals negative 2x squared plus 12x minus 7. The vertex is 311. We're going to give that to you. Next year, we will be teaching you how to find this vertex. It's not very hard. Trust me, it's not that big a deal. So what else do we know just by looking at this? We know a few things. We know that this right here, the constant term, is always going to give us the vertex, or excuse me, the y-intercept. Ooh, so I guess I can write that right down here. I should probably stick with my order, shouldn't I? 0, negative 7 is our y-intercept. We can tell whether it opens up or down. In this case, it's going to open down because negative 2 right here is less than 0, so it's going to open down. The equation for the axis of symmetry is x equals 3. That comes from here. The axis of symmetry goes through the vertex. Since there's the x-coordinate of the vertex, that right there is the equation for the axis of symmetry. I'll talk about that more when we graph it. And what's 1 point left and 1 point right? We want to go over 1 in each direction. And in this case, we're going to go down 2. Down 2 because of this -2 right here. Hey, if you need to pause and grab some highlighters, I highly recommend it. So what do we need to do to start? We need to plot the vertex. That's over 3 and up 11. And we know it's going to open down, so it's going to look like this. The equation of the axis of symmetry is x equals 3, so that's right here. So this is x equals 3. This is 3, 11. I like to label all of the critical points. To get 1 point left and 1 point right, we're going to go from the vertex. I cannot emphasize that enough. 1 left and down 2, and 1 right and down 2. And then we know that the vertex is 0, -7. Ooh, that's way down here. So we have now 1, 2, 3, 4 points. To get a 5th point, we can go 1, 2, 3, 1, 2, 3, over to there. This is kind of hard to draw because of that long curvy part right there. Again, I mentioned before, you don't want to make this pointy. You want to put some slight curve there. So I'm going to graph this, 0, -7. Those are the minimum number of points that you should label, but I want to see dots right there. I want to see the dots right there. If you feel really comfortable with this, you can stop right now, but I'm going to do 2 more examples on the back page.